So we can shorten that electron configuration by looking at the noble gas version of it. And the way that we do that, let me give you a quick example. Let's say that we were noble gas configuring scandium, all right? So if we look at where scandium is on the periodic table, element number 21 right here, right now there are quite a few different elements that we need to, quite a few different subshells we need to fill to get the full electron configuration for scandium. So you guys already have that in your notes. But if I was doing it from scratch, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. So the way that we would abbreviate that is to look back to the previous row at the end and see what noble gas was there. So it looks like the noble gas that we get to right before we get to scandium is argon. So our shorthand version of scandium's electron configuration is to say that scandium has all the same electrons that argon has. And remember that argon has all of these electrons in it. And then after that, we can just write the last row of the configuration ourselves. So chemists use this shorthand because electron configurations can get really long. Will I let you use it on a test? I don't know. Maybe, maybe not. All right? Maybe or maybe not. But in real life, practicing chemists use this as a shorthand for electron configurations very often. So if we look at carbon, for example, the nearest noble gas at the previous row is helium. So we could shorten, quote unquote, carbon's electron configuration to all the same crap that helium has plus 2s2, 2p2. So let's look at calcium for a second, all right? So if you look at your periodic table, see if you can track that you're filling 1s, then 2s, then 2p, then 3s, then 3p, then 4s. So look across each one of those blocks so we can use our periodic table. And remember that even though we're in the fourth row, we're not filling the 3D subshell yet because we fill 4s before we fill 3D. So there's our electron configuration for calcium. If we were doing the noble gas version of that, this is all the same stuff that argon has. And then after that, just the fourth row is 4s2. So that's our shorthand version of the electron configuration. Remember again how to identify what block you're in so you can tell which kind of subshell you're filling. So those two columns on the left are the S block. The columns of 6 across are P block. The transition metals form the D block. And then don't worry about the rare earth elements. Those are the F block, but we're never going to write an electron configuration that's big enough to have F electrons in it, just beyond what we need to do for this class. So hopefully you guys have learned a little bit about how to write a good electron configuration. If you want more practice with this, it is kind of a hard skill, so I'm more than happy to help you guys practice during our normal recitation times.